Okay, so we're saying graphs of rational functions. And we go straight to examples. Sketch a f of x is equal to 8x plus 6 over 4 minus 2x. And b, f of x is equal to 2 over x squared minus x. I think minus 12, okay. Now we can go to the solutions. So here, 1, f of x is equal to 8x plus 6 over 4 minus 2x. So we're seeing steps. I think they're still important. So let's just redo them. Step 1, we find the vertical asymptote. Then there's a question of how. Then we are saying by equating the denominator to 0 and solving for x. Step 2, find the horizontal asymptote how the answer by finding the limit as x goes to infinity of f of x. Then 3, we find the y-intercept. Again, how? We answer it by substituting x is equal to 0 in the function f of x. Part 4, step 4, find the x-intercept. How? The answer is by equating the numerator to 0 and solving for x. If you don't forget this, then you'll never miss a question on rational functions. You always get it right. So we'll move slowly, especially on part 2. so that we can understand it and then use it going forward. So we'll move to the next page. That's why I'm going to answer this question A for. So A, f of x is equal to 8x plus 6 over 4 minus 2x. 4 minus 2x. So we start. We get the vertical asymptote. What do we discuss? By equating the denominator to 0, and then we solve for x. We divide by -2. The answer turns out to be x is equal to +2. Step 2, we get the horizontal asymptote. How? By getting the limit as x goes to infinity of the function f of x, meaning 8x plus 6 over 4 minus 2x. Now, how do we do this? I know we haven't learned this in class, but we are learning here. So how do you do this? You say, okay, this is the limit as x goes to infinity, and then you factor out x, the highest degree of x that is in the denominator. You don't go to the numerator, you go to the denominator and look for the highest degree of x. In this case, the highest degree of x is this one here, x to the power 1. So we'll factor out x in the denominator. Remember factoring out like we are doing in completing the square. When you factor out, it will divide throughout. So we'll have 4 over x minus 2, because it will be 2x over x, which is just 2. When you do that, you take this same x, you take it in the numerator and factor it out there. So you divide through, so we'll have 8 plus 6 over x. Then, when you do that, you see that this x and this one down, they can now cancel. And then you remain with the limit as x goes to infinity of 8 plus 6 over x over 4 over x minus 2. Then note that we have this fact here, that the limit as x goes to infinity of any number a over infinity, over x, of n number a over x is equal to 0. Okay, so the limit as x goes to infinity of n number a over x is equal to 0, where a is any real number. That limit there is equal to 0. So we use this fact here. So we'll say this means that we now have the limit as x goes to infinity of 8 over -2, because we are saying this is 0 and this is 0. Okay, so this is 0 on top and this is 0 down. So this will give us -4. Maybe we should also note that the limit as x goes to any number b of any constant c is equal to the number c, where a and b are real numbers, where C and B, where C and B are any real number. While here we also include infinite. So that's the reason why as x goes to infinite of the constant -4, we still get the answer -4. So the horizontal asymptote in this case is, so the horizontal asymptote is the line y is equal to -4. Then we get the x, the y-intercept. The y-intercept, we said by taking 0 where there is x, so we'll have 6/4, which is equal to 3/2. And then the x-intercept, we said by equating the numerator to 0, so we get 8x plus 6 is equal to 0, implying that x is equal to -6/8, which is -3/2. Then now we can have the sketch of this function. So we have, yes?
Sorry, but where did the 6/4 come from? Finding the y-intercept.
The y-intercept. Oh, we're substituting in f where there is x, we are taking 0.
Okay.
Sir, I'm a bit confused on the horizontal asymptote.
So even I'm a bit confused how we are finding the intercept.
The intercept. Okay, let's start with the y-intercept. Then I'll get
No,
back.
the horizontal asymptote.
Okay, let's start the horizontal asymptote. The horizontal asymptote, you're getting the limit as x goes to infinite. The question is, how do you get the limit? You factor out x, the highest degree of x in the denominator. Then that same highest degree, you take it up and factor it out from the numerator as well. Even if it's not the highest in the numerator. And then you make use of these two facts here. The first one is that the limit as x goes to infinite of n number over x is 0. And the limit of n constant is the constant itself. And by using that one, you find yourself having this part here 0 and this part here 0. Then you have 8/-2, which is just -4. The intercepts. How do you get the y-intercept? You go to the function where there is x, you put 0. So when I put 0 here where there is x, I'll have 8 times 0, which is 0. So I'll remain with 6 in the numerator. So I have a 6. When I put 0 here where there is x in the denominator, I'll have 4 minus 0, which is just 4. Then when you simplify, you divide by 2, you get 3/2. The x-intercept, remember the note here was saying, the x-intercept, you equate the numerator to 0. Equate the numerator to 0. So the numerator is 8x plus 6. We equate it to 0 and then solve for x. So if you take this other side and divide by 8, we get -3/4. Then now we plot what we have. We have y is equal to -4 as the y asymptote, which is the horizontal asymptote, -4. Then we also have x is equal to 2 as the vertical asymptote, 2. Then we sketch. You got the vertical asymptote and get a number that is bigger than 2, say the number 3, and take it in the function. So you have f of 3 giving us 8 by 3, that's 24, plus 6 over 4 minus 4 minus 2 by 3, that is 6. So we get 30 over negative 2, which is negative 15. This number is less than negative 4, meaning that the graph is going to be down here. So you check the number you get if it's bigger than the horizontal asymptote or less. Then the other side, we already know the x, we already know the y-intercept is 3 over 2. So meaning that this graph is going to be up here. We also have a x-intercept to be negative 3 over 4. So the graph is complete there. I think we had something like this in the test, except that the horizontal asymptote was now up. It had this behavior. Let's ask questions now based on this one, because it seems the time I was logged out, the meeting did not cut. I was thinking it cut so that we have the whole 40 minutes, but seems it did not cut, and then it's counting down now to less than 3 minutes. It will be cutting.
Sir, can you repeat on the graph, like just on the plotting for the graph, where you said that f of u is equal to 24 plus 6, then why you got to 15, negative 15 from?
So when we plot what we have here, we have the vertical asymptote, which is x is equal to 2. You plot a line. We also have the horizontal asymptote, which is negative 4. You also plot a line. You now have two lines. You go to the vertical line and pick a number bigger than the value that is giving us that line. So you pick a number bigger than 2, say 3. When I pick 3, I will take it in the function f and observe the value I get. What value do we get? We get negative 15. The question is negative 15 bigger than the horizontal asymptote or less? We find that negative 15 is less than the horizontal asymptote. This means that the graph will be on the right of 2 and below negative 4. So that's how we put it here.
Okay, now I understand it, sir. Thank you.
Any question? We still have a minute. Yes. Okay, so what we'll do is
if you were to solve a question without adding that, you just do that simple method where if the numerator is greater than the denominator, you divide the coefficient of x. You do that one instead of, is that like 3? Is that still math or the math is deducted?
It's the same thing.
Huh?
It's the same thing. You get the same marks, same answer.
Sir. Sir.
Okay, so
then for the second graph, did you plug in the values in the function or you just created it? I can't understand.
We plugged in these values. We found these values. So we just plotted them. Okay, okay. Yeah, so let's rejoin.